Hey, curious minds! Welcome back to Creative Minds. Today we've got something special for you. 10 mind-blowing facts that will leave you amazed. Some of these are so out there you'll think I'm making them up. But I promise, they're all true. Get ready to explore the unbelievable side of our universe, from the depths of space to the quirks of our own planet. We'll uncover hidden wonders, challenge your assumptions, and leave you with a sense of awe and wonder. So buckle up and let's dive in. Imagine you're an astronaut, suited up for a spacewalk, gazing out at the cosmos. You see the Earth, a vibrant blue marble against the backdrop of the infinite black void. You see the distant stars, twinkling like celestial fireflies. It's a scene of breathtaking beauty, but there's one crucial element missing: sound. You see, space is a vacuum, and sound as we know it cannot exist in a vacuum. Here on Earth, sound travels through the air as vibrations. When something makes a sound, it causes the air particles around it to vibrate. These vibrations then travel to our ears, where our brains interpret them as sound. But in space, there are no air particles to vibrate. It's an empty, silent void. If you were to shout at the top of your lungs while floating in space, no one, not even someone right next to you, would hear a thing. This is why astronauts use radios to communicate with each other in space. Radios transmit electromagnetic waves which, unlike sound waves, can travel through the vacuum of space. These waves carry the astronauts' voices to each other, allowing them to communicate even in the silence of the cosmos. However, it's not entirely true to say that space is completely devoid of sound. While our ears can't detect them, there are faint sounds in space, like the whispers of the universe itself. These sounds are caused by electromagnetic vibrations and plasma waves. In fact, in 2012, NASA's Voyager 1 spacecraft, which has traveled farther than any other man-made object, detected the sounds of interstellar space, the space between stars. These eerie, almost musical sounds are caused by the interaction of interstellar plasma with the solar wind. So, while our ears might perceive space as silent, it's actually humming with activity, a symphony of cosmic sounds beyond our human perception. We often think of ourselves as solid, tangible beings. But what if I told you that we emit light, that each of us is a walking, talking source of luminescence? It's true. The human body in all its complexity actually glows. This glow, invisible to the naked eye, is a phenomenon known as biophoton emission. It's the result of the countless biochemical reactions happening inside our cells. Our bodies are constantly at work, breaking down nutrients, building new molecules, and producing energy. These processes release tiny packets of light called photons. Now, before you start picturing yourself lighting up a room, I should clarify that the light we emit is extremely faint. In fact, it's about 1,000 times dimmer than what our eyes can detect. To put it into perspective, it's like trying to see a single firefly in the middle of a brightly lit city. However, with the help of specialized cameras, scientists have been able to capture this faint glow, revealing a fascinating aspect of our biology. Interestingly, the intensity of our glow isn't constant. It fluctuates throughout the day, following our circadian rhythms. Our faces, in particular, emit the most light in the late afternoon, gradually dimming down as night approaches. This suggests a possible link between our biophoton emissions and our internal biological clock. While the exact purpose of this glow remains a mystery, some scientists believe it might play a role in cell communication, allowing cells to send signals to each other using light. Others speculate that it could be a byproduct of our metabolism, a visual indicator of the energy flowing through our bodies. Whatever its function, the fact that we glow, however faintly, adds another layer of wonder to the already remarkable human body. When we think of clouds, we usually picture fluffy, white formations drifting across our sky. But what if I told you that there's a cloud out there in the vast expanse of space, a cloud so massive that it dwarfs our entire planet? This isn't science fiction. It's a real discovery made by astronomers using powerful telescopes. This colossal cloud, located about 10 billion light-years from Earth, is a gigantic reservoir of water vapor, a cosmic oasis in the otherwise dry expanse of space. To give you an idea of its sheer scale, this cloud is estimated to be 100 times larger than our Earth. That's like comparing a basketball to a grain of sand. And when it comes to water content, this cloud puts our oceans to shame. It holds an astounding 140 trillion times more water than all the oceans on Earth combined. Now you might be wondering how a cloud of water could exist in space, where temperatures are unimaginably cold. Well, this cloud isn't your average rain cloud. The water in this cloud is heated to a scorching 300 degrees Celsius, hotter than the boiling point of water here on Earth. The heat source? A supermassive black hole at the center of a distant galaxy. As matter swirls around the black hole, it heats up, generating intense radiation that keeps the water in a gaseous state. This cloud is a testament to the fact that water, one of the essential ingredients for life as we know it, can exist in the most extreme environments, even in the heart of a distant galaxy, billions of light years away. Chapter 4: Octopuses have 3 hearts. Octopuses, with their 8 arms, bulbous heads, and incredible intelligence, already seem like creatures from another world. But their alien-like nature goes even deeper than their appearance. These fascinating cephalopods possess a physiological quirk that sets them apart from most creatures on Earth. They have 3 hearts. 2 of their hearts, known as branchial hearts, are dedicated to pumping blood through their gills. Just like our lungs extract oxygen from the air, gills extract oxygen from water. The octopus's gills are highly efficient, allowing them to thrive in the ocean depths. The 3rd heart, called the systemic heart, circulates the oxygenated blood to the rest of the body, providing energy for their muscles and organs. This 3-heart system is a marvel of evolution, an adaptation that allows octopuses to thrive in the demanding underwater environment. But here's where it gets even stranger. When an octopus swims, its systemic heart, the one responsible for circulating blood to the body, temporarily stops beating. This is why octopuses often prefer to crawl along the ocean floor, using their arms to propel themselves forward. Swimming, with its stop-and-start heartbeat, is a much more energy-intensive activity for them, and if that wasn't strange enough, octopuses also have blue blood. Unlike our iron-rich red blood, octopus blood contains a copper-rich protein called hemocyanin. Hemocyanin is highly efficient at transporting oxygen in cold, low-oxygen environments, making it perfectly suited for their deep-sea lifestyle. Chapter 5: The Eiffel Tower grows taller in summer. The Eiffel Tower, that iconic symbol of Paris, standing tall against the Parisian skyline, might seem like an unchanging monument. But what if I told you that this iron giant isn't as static as it appears? The Eiffel Tower, like most things made of metal, is subject to the laws of physics, specifically a phenomenon known as thermal expansion. You see, when metal heats up, its molecules move faster and spread slightly further apart, causing the metal to expand. During the hot summer months in Paris, when the sun beats down on the Eiffel Tower, the iron structure absorbs heat, causing it to expand. And because the Eiffel Tower is so tall, even a small amount of expansion per degree of temperature change can add up to a significant height difference. On average, the Eiffel Tower can grow by as much as 6 inches or 15 centimeters during a particularly hot summer day. That's taller than the average basketball. Of course, this expansion and contraction aren't visible to the naked eye. However, engineers have to take thermal expansion into account when designing and building structures, especially large structures like bridges and skyscrapers. They incorporate expansion joints and other design elements to accommodate these changes in size, ensuring that the structure remains stable and safe. So, the next time you see a picture of the Eiffel Tower bathed in the warm glow of the summer sun, remember that it's not just an illusion. The tower is actually taller than it is on a chilly winter day, a subtle reminder that even the most seemingly unchanging structures are subject to the dynamic forces of nature. Chapter 6: Honey never spoils. Honey, that liquid gold produced by bees, has been a prized sweetener for millennia. But honey's appeal goes beyond its sweet taste. It possesses an almost magical quality. It never spoils. That's right, honey, unlike most foods, has an incredibly long shelf life, potentially lasting for centuries. Archaeologists have unearthed jars of honey in ancient Egyptian tombs, sealed away for thousands of years, and guess what? The honey was still perfectly edible. This remarkable longevity is due to honey's unique composition, a perfect storm of factors that make it inhospitable to bacteria and other microorganisms that cause spoilage. Firstly, honey has a very low water content. Bacteria and other microorganisms, like all living things, need water to survive. Honey's low moisture content creates a harsh, dry environment where these microorganisms simply can't thrive. It's like trying to grow a garden in the middle of a desert. Secondly, honey is naturally acidic. Its pH level ranges from 3 to 4.5, acidic enough to inhibit the growth of most bacteria. Think of it like preserving food in vinegar or lemon juice. The acidity creates an environment that's hostile to spoilage-causing microbes, and if that wasn't enough, honey also contains an enzyme called glucose oxidase. Bees add this enzyme to honey while they're making it. Glucose oxidase breaks down glucose in the honey, producing hydrogen peroxide as a byproduct. Hydrogen peroxide acts as a natural antiseptic, further inhibiting the growth of any stray microbes that might find their way into the honey. So there you have it, a trifecta of preservation, low moisture, high acidity, and natural antiseptic properties. It's no wonder honey can last for centuries. Of course, proper storage helps. Keeping honey in a sealed container away from heat and humidity will ensure that it stays fresh and delicious for generations to come. Let's dive into the fascinating world of botany, where things aren't always as they seem. Today's subject: the surprising truth about bananas and strawberries. Prepare to have your fruit-based assumptions challenged. You might be surprised to learn that, botanically speaking, bananas are classified as berries, while strawberries are not. I know it sounds like I'm pulling your leg, but hear me out. The classification of fruits and vegetables is based on their botanical structure, specifically, how they develop from the flower. A berry, by definition, is a fruit that develops from a single ovary in a flower and contains one or more seeds. Now let's look at the banana. It develops from a single ovary in the banana flower and contains tiny, edible seeds, though cultivated varieties have had their seeds bred out for our convenience. So, by definition, the banana fits the bill of a berry. Strawberries, on the other hand, are a bit more complex. While they might look like a single fruit with seeds embedded on the surface, they're actually what's known as an aggregate fruit. This means that they develop from a single flower with multiple ovaries, and each of those tiny white specks on the strawberry is a separate fruit, each containing a single seed. So, while we commonly refer to strawberries as berries, they're technically a collection of small fruits attached to a fleshy receptacle. It's a bit mind-boggling, I know, but that's the beauty of botany. It challenges our assumptions and reveals the hidden complexities of the natural world. Chapter 8. A day on Venus is longer than a year. Venus, our closest planetary neighbor, often shrouded in a veil of thick, swirling clouds, holds a rather bizarre distinction in our solar system. A day on Venus is longer than a year on Venus. Now that might sound like a riddle, but it's a strange and true fact about this enigmatic planet. Here on Earth, we're accustomed to a day lasting 24 hours, the time it takes for our planet to complete one full rotation on its axis. A year, on the other hand, is the time it takes for our planet to complete one full orbit around the Sun, which is approximately 365 days. On Venus, however, these familiar concepts are turned upside down. Venus rotates on its axis incredibly slowly. In fact, it rotates so slowly that a single rotation takes a whopping 243 Earth days to complete. That means a single day on Venus lasts longer than it takes for Venus to make a complete orbit around the Sun, which takes only 225 Earth days. So, if you were to stand on the surface of Venus, ignoring the unbearable heat and toxic atmosphere, of course, you'd experience a day that stretches on for what would seem like an eternity, while the Sun would slowly arc across the sky, rising in the west and setting in the east. That's right, Venus also rotates in the opposite direction to most planets in our solar system, adding another layer of peculiarity to this already strange world. The reasons for Venus's sluggish rotation and retrograde rotation remain a mystery, but scientists speculate that it could be the result of a massive collision with another celestial object early in its history. Whatever the cause, Venus's bizarre day-night cycle is a testament to the incredible diversity of planets in our universe. Chapter 9. You can't hum while holding your nose. Go ahead, give it a try. Try humming a tune while firmly holding your nose closed. What do you notice? You can't do it. It's a simple experiment, one that you can try right now, and yet it reveals a fascinating connection between our ability to hum and our anatomy. Humming, that melodic sound we produce without forming words, relies on the flow of air through our vocal tract, which includes our throat, mouth, and nasal cavity. When we hum, our vocal cords vibrate, producing sound waves. These sound waves then resonate within our vocal tract, amplifying and shaping the sound. Our nasal cavity, the space behind our nose, plays a crucial role in this process. It acts as a resonating chamber, adding depth and richness to the sound of our hum. When we pinch our nose closed, we block the flow of air into and out of our nasal cavity, effectively cutting off this resonating chamber. Without the nasal cavity to amplify and shape the sound waves, the sound becomes muffled and weak. It's like trying to play a flute with the end closed off. The sound simply can't resonate properly. This simple inability to hum while holding our nose highlights the interconnectedness of our body systems. Our ability to produce even the simplest of sounds relies on the coordinated action of our muscles, bones, and air passages, a delicate interplay that we often take for granted. Chapter 10. There are more stars in the universe than grains of sand on Earth. Look up at the night sky on a clear night far from city lights, and you'll be greeted by a breathtaking sight, a canvas of twinkling stars, each one a distant sun, many much larger and brighter than our own. It's a humbling sight, one that makes us feel incredibly small. But what if I told you that the stars you see represent just a tiny fraction of the stars that exist in the universe? In fact, the number of stars in the universe is so vast, so mind-bogglingly large, that it dwarfs even the number of grains of sand on all the beaches on Earth combined. Astronomers estimate that there are roughly 100 billion stars in our galaxy, the Milky Way, alone. That's 100 billion stars, more stars than there are people on Earth by a factor of over 10,000. And the Milky Way is just one of billions, perhaps even trillions of galaxies in the observable universe. Now, try to imagine the number of grains of sand on all the beaches and deserts on Earth. It's a number that's hard to fathom, but it pales in comparison to the estimated number of stars in the observable universe, which is thought to be in the region of 10 sextillion. That's a 1 followed by 22 zeros, a number so large that it's hard to even comprehend. Each of those stars is a sun, a giant ball of burning gas, just like our own. And many of those stars, perhaps even most of them, have planets orbiting them, just like our solar system. The sheer vastness of the universe, the sheer number of stars and planets out there, is enough to make one's head spin. So, the next time you look up at the night sky and feel a sense of awe and wonder, remember that you're looking at just a tiny glimpse of the universe's true grandeur. There are more stars out there than you could ever count, more stars than grains of sand on all the beaches on Earth, each one a testament to the universe's boundless capacity for creation. And that's it. 10 incredible facts that will blow your mind. From the silent depths of space to the hidden wonders of our own bodies, the universe is full of surprises waiting to be discovered. If you loved learning about these surprising truths, don't forget to hit the like button and subscribe for more mind-bending content. Until next time, stay curious.